Hello everyone. The next acidic comparison will be among these molecules: orthochlorophenol, metachlorophenol, parachlorophenol. Topic is involved for 12th, JEE and NEET. Let's check. The same technique I am going to show. I will make anions after loss of H positive and then I will compare the stabilities of those anions. This is the anion which is developed due to loss of H positive from orthochlorophenol. Anion generated from metachlorophenol. Anion generated from parachlorophenol. After loss of H positive, which molecule is creating most stable anion, that we will check. Which atom is unstable? Oxygen, because it is carrying -1 charge. So now we will check all the factors by which this oxygen is getting stability as well as destability. Then we will conclude it. So the very first factor I am watching here is plus R effect of oxygen, which will stabilize it, because with the resonance the negative charge of oxygen will finish. This effect is all present here also. In all cases this effect is there. Due to plus R of O, it is getting stability, so I will write here stabilizing factor S. Because this factor is available in all three cases, so only this factor can't decide the stability order. Go for next. Here we have substituent. Now we will check what substituent is doing here. As you know, chlorine making single bond always carry 3 lone pairs. Atom attached to benzene ring, if carrying lone pairs, it will always show plus R effect. Already discussed. Plus R of Cl. Plus R means it will donate lone pair in a resonance. In previous videos, please check. In previous video, I told you from meta position, if it will donate electrons in resonance, means plus R effect it will show, but those electrons will not come on this carbon. Means this oxygen will not be affected by plus R of Cl, which is present on meta position. So here I will not write it. From para position, if it will show plus R effect, electrons will come on this carbon, which can affect the stability of this oxygen. So here I will write plus R effect of Cl is operating. And you know, plus R of substituent will try to destabilize D dot S. It's a destabilizing factor. Because when electrons will come on this carbon due to resonance of substituent, those electrons will repel electrons present between carbon and oxygen, due to which these electrons will move toward oxygen, which will increase the negative charge. And if negative charge is increasing, oxygen will become destable. Third factor which this substituent is showing, chlorine is more electronegative than carbon. So it is attracting electrons due to electronegativity difference. As it will attract electrons, so all the electrons will move toward chlorine side. This effect is known as -I effect of chlorine. Due to -I effect of chlorine, if these electrons will move toward carbon, the negative charge of oxygen will decrease. So -I of Cl will try to stabilize the anion. So I will write here S. Here also we have -I effect. All these effects we have discussed in previous videos. Please check them and then watch these videos where I am using directly them. Okay. Now I told you minus I effect depends on distance. Here chlorine is closest to oxygen, so here it is showing strongest minus I effect. As distance will increase, the minus I effect will less affect oxygen. And here we can say we are watching weakest minus I effect of chlorine on oxygen. So here we have weakest. It is a stabilizing factor. It is a stabilizing factor. Now only this factor can't decide the overall stability order. So let's remove it because this factor is saying all three are equally stable. But watch this factor. Now plus R in this case is saying to destabilize it. Minus I is trying to stabilize it. In previous video I told you in the case of chlorine, bromine, iodine, minus I effect will dominate. Reason already explained. So means overall this anion will become stable. Here also destabilizing factor is there plus R and stabilizing factor minus I is there. So as I told you, minus I effect will dominate over plus R effect in the case of chlorine, bromine and iodine. Means overall these all anions will become stable. Okay. Now which anion will be most stable? Because minus I effect is deciding the stability. So stronger the minus I effect, more stable will be the anion. So where we have strongest minus I effect? Here. So this will be the most stable anion. This will be the most unstable anion. If we compare these three, that's it. We got the stability order. Because two factors were there, one was saying destabilize, one was saying stabilize. So stabilizing factor is dominating, means overall this anion will be stabilized. Now which will be most stable, which will be least stable? It depends on the power of I effect. In ortho, the minus I effect is strongest. In para, the minus I effect is weakest. So this will be the most stable and this will be the most unstable if we compare these three. So the stability order will be this is first one, this is second, this is third. Stability order of anions. Increasing order I am writing. So which will be the least stable? Third one, para chlorophenol. Then second is more stable than third, and most stable will be 1. The negative charge of oxygen will decreased here most. This one. So on a basis of that we can get acidic order. This anion was generated by this molecule, orthochlorophenol, after loss of H positive. Now this molecule knows that after loss of H positive, I will get most stable anion among these three. So it will lose H positive very easily. And as it will lose H positive easily, it will become most acidic. So the acidic order will be same like a stability order of the anions. Para-chlorophenol will be the least acidic. Meta will be more acidic. And ortho will be most acidic case here. Okay. Now the same pattern always will be followed by bromine and iodine also. If we have to compare orthobromophenol acidic order with metabromophenol, and para it will be most acidic and para will be least acidic. Reason is same, minus I effect. Here minus I effect is most and here minus I effect is least, because in previous video I told you this chlorine, bromine, iodine, both are showing two type of effects, plus R and minus I. Plus R wants to destabilize the anion, minus I wants to stabilize. Here it is dominating. Minus I effect is dominating, and minus I effect depends on distance. As distance will increase, its power will decrease. Same for iodine. That's it in this video, this comparison. And if I compare them, like I am comparing orthochlorophenol or whatsoever the chloro, meta or para, between normal phenol and this, which will be more acidic? So very easy. Check. Draw its anion. Compare their stabilities. The very first factor which is making them stable, it will be normal plus R of O. The first factor you can write plus R of O plus R of O. Second factor, anything is not available here, no substituent, so no need to write. Here second factor is plus R of Cl, because it is on ortho position, will try to destabilize. It is a stabilizing factor, it is a stabilizing factor. Okay, and third factor which is not available here, here it is available, that is minus I effect, which will try to stabilize. This factor can't decide the stability order, so you can leave it. Here, which will dominate? This factor will dominate. Okay, means this anion is getting stability by two factors, plus R of O and minus I of Cl. Two factors are stabilizing it. But here only one factor is stabilizing it, means this is more stable. This is more stable. If it is more stable, so the molecule from which it was drawn, means orthochlorophenol will be more acidic than normal phenol. So note this comparison also. All halophenols are more acidic than normal phenol. Reason same, minus I effect of chlorobromoiodo. Fluorine case in next video I will add. Thank you very much for watching the video.